This is Professor Pelton. This is Trigonometry, Chapter 4, Section 1, Verifying Trigonometric Identities. This is Part 2 of 2. Okay, so this time we're going to be adding some fractions together that don't have common denominators and breaking them apart, so on and so forth. So let's first start with this one here. So you see here that I need to get this down to one term, but I have two terms to start with. So the result is I need to make common denominators, but what I have here so far is neither one has a common denominator. So this left one is missing a cosine, so I'll multiply it by a cosine over cosine. And the right-hand fraction is missing a 1 plus sign, so I'll multiply that by 1 plus sign. Okay, just going to leave off the 2 equals 2 cosine at this point. So this fraction went to here, and this fraction went to here. We can do some simplifying now. So the top of the first one becomes cosine squared of x over the common denominator of cosine of x times 1 plus sine of x, plus, and if we distribute over here, let's give her some arrows, we're going to get a 1 right here. And a sign there. And a sign there. And a sign squared there. Okay, all over the cosine times 1 plus sine. Okay, so we can combine the tops now, and we get cosine squared plus 1 plus 2 sine of x plus sine squared of x equals our cosine of x, 1 plus sine of x. Okay, so we notice on the top here is I have a cosine squared and a sine squared. Remember that cosine squared plus sine squared is 1, correct? So as a result, I'm going to get 1 plus 2 times sine of x over the denominator, which is cosine of x, and 1 plus sine of x. So I can combine the two, 1 and 1 to get a 2, so 2 plus 2 sine of x over the denominator of cosine of x, and 1 plus sine of x. Since there's a common 2 in the top, I can factor it out the 2 and be left with a 1 plus sine of x when I factor the 2 out. And on the bottom I still have my cos of x and 1 plus sine of x, which now will cancel, leave me with 2 over cosine of x. But cosine, or 1 over cosine, is secant, so that's actually 2 times secant of x, which we notice that was the original piece. So equals 2 secant of x equals 2 times secant of x, 2 times secant of x, 2 times secant of x, and 2 times secant of x. Alright, we've proved it. Pause the video, try the student problem. Alright, student problem. Let's make common denominators. So common denominator here, they have nothing in common. So the common denominator is going to be a combination of both, which is sine times 1 plus cosine. So the first one's missing a sine. Alright, so the first fraction went there. And the second one's missing a 1 plus cosine. Okay, and the second fraction went there. Okay, so we can simplify the fractions. The first fraction becomes sine squared over the common denominator. Plus, with the common denominator in the bottom, which is sine of x times 1 plus cosine of x. And if we distribute the top, we'll get a 1. We'll get a cosine. We get another cosine. And a cosine squared. Okay, so if we combine the tops again, we get sine squared of x plus 1 plus 2 cosines plus a cosine squared all over the common denominator. Okay, and again we notice that sine squared plus cosine squared is 1. So add that to the other one there, we get a 2. So we get 2 plus 2 cosine of x over the common denominator. Okay, and the numerator has a common factor of 2 we can factor out. So that's going to be 1 plus cosine all over sine times 1 plus cosine, which is now a common binomial that can cancel, leaving me with 2 over sine. The reciprocal of sine is cosecant, so I'm left with 2 times cosecant, which just happens to be what I was looking for here. You're welcome to recopy that if you want, but we got our answer. Okay, let's go to the next problem. Okay, variety of ways to do this one. You can multiply by the conjugate. So instead of 1 plus cosine, you can multiply by 1 minus cosine. Or we can just simply cross multiply. That would work too. So we cross multiply. I get sine squared of theta equals, we'll cross multiply here. That's 1 plus cosine times 1 minus cosine. Oops, not a square there. I don't know why I did that. Okay, so if we distribute now, sine squared of theta equals 1 minus cosine plus cosine minus cosine squared. So sine squared of theta equals 1. Those will go away. Minus cosine squared of theta. Make a better squared than that. Okay, so we're almost there. And what I remember is the Pythagorean identity says sine squared plus cosine squared is 1. And if I subtract the cosine, I'm left with sine squared of theta equals 1 minus cosine squared of theta. using the identity. So the reality is, this is sine squared, based on the Pythagorean identity. So sine squared is sine squared. We've proved it. Alright, pause the video and try the student problem. Okay, student problem, we'll cross multiply. So we get cosine squared of theta equals 1 plus sine of theta times 1 minus sine of theta. So cosine squared of theta equals, distribute 1, distribute negative sine of theta, positive sine of theta, and negative sine squared of theta. So those cancel. So cosine squared of theta equals 1 minus sine squared of theta. What I remember from my Pythagorean identities is cosine squared of theta plus sine squared of theta equals 1. So if I subtract the cosine, I'm left with sine squared of theta equals 1 minus cosine squared of theta. Thus this is, oops, I did it the wrong way that time, minus sine this time, I'm sorry. So if I minus sine from both sides, I'm left with 1 minus sine squared equals cosine squared. Right, that's the value of cosine squared, which is this right here. So cosine squared of theta equals cosine squared of theta. Okay, and we proved it. Okay, let's try the next page. Okay, so we got a few things going on here. So we clearly have to condense this down quite a bit to get the tangent, which means we need to combine things. So first off is the negative. So using the final rules on our previous chapters, the odd-even rules, if it's a sine, then the negative goes to the outside. So I have tangent of x minus a negative sine of x over 1 plus cosine. So as a result, the negative goes away. I'm going to swap the tangent for sine over cosine using its quotient identity. And I'll make the sine and over 1. Okay, so again, the end goal here is to combine these things to get it down all the way to a tangent. Well, I notice the denominator here, the common denominator, is cosine. So I'm missing a cosine over here, so I'm going to multiply by that by cosine over cosine to get the common denominator. So that gives me sine of x over cosine plus sine of x cosine of x over cosine all over 1 plus cosine of x. Okay, now we can add the numerators, and I will get sine of x plus sine of x cosine of x all over the common denominator of cosine all over the denominator of 1 plus cosine, and the whole thing equals my tangent still. Okay, so we're getting there. Okay, so what we should notice is they have a sine in common. We can divide out on the top. So if I do that, if I take out a sine, I'm left with 1 plus cosine over cosine all over 1 plus cosine. But the sine over cosine is tangent. So I'll have a tangent of x times 1 plus cosine of x over 1 plus cosine of x, which will in fact cancel, leaving me with tangent. We verified it. All right, pause the video, try the student problem. Okay, so same thing here. We want to condense, looks like we want to break this into two parts this time. So we want to get it into two parts. So we're going to have to do some things to move things around. So first off is the negative. It's using the odd-even rule. The negative for cosecant is equivalent to the sine, because cosecant is sine, goes on the outside. So in fact, we have secant of x minus cosecant of x over secant of x cosecant of x. Okay, so the goal here is to get two terms this time, so we're going to break the fraction apart. So we get secant of x over secant cosecant minus cosecant of x over secant cosecant. So cancel, 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 cancel. These are supposed to equal sine minus cosine, sine minus cosine. But we have 1 over cosecant after the canceling, minus 1 over secant after the canceling. So we have the minus, but we don't have sine or cosine. But using the reciprocal identities, we can change 1 over cosecant into sine, and secant into cosine using the same identity, equals sine of x minus cosine of x, and we've proved it. Okay, let's try the next problem. Okay, so again, we want to combine things here probably, but what I'm noticing here is I don't have common denominators, right? So this is missing a 1 minus cosine, and this one's missing a 1 plus cosine. So I'm going to multiply this one by 1 minus cosine over 1 minus cosine. And this one's missing a 1 plus cosine, so 1 plus cosine over 1 plus cosine times the 1 over 1 minus cosine. Okay. So now let's condense these. So 1 times anything is itself on the top. So 1 times that is itself. So as essentially, I have a 1 and a 1 gives me 2. And then the negative cosine and the positive cosine go away. And on the bottom, I'm left with 1 minus cosine and 1 plus cosine. And I can distribute that through. So 1 times 1 gives me 1. Cosine times 1 times cosine is cosine. Negative cosine times 1 is negative cosine. And negative cosine times cosine is negative cosine squared. So as a result, those cancel. So I'm left with 2 over 1 minus cosine squared. And 1 minus cosine squared is the Pythagorean identity, so that's 2 over sine squared of x. Well, I'm trying to get this though, but I'm not quite there. But that's two things, but I ended up with one thing. So I didn't quite get there. So I need to combine the top what's in the circle to match what's in the box. So the box is one thing, the circle is two things. I need to combine them. So I'm going to take that over to the right, and I'm going to condense those now into one thing. So if I do that, I get 2 plus 2 times cosine squared over sine squared. So I'll make them both fractions now, right? So this went to there. I made the cotangent cosine over sine, so I can make fractions. So the common denominator here is sine squared. Okay, so that means we need to multiply the 2 over 1 by a sine squared. So sine squared of x over sine squared of x times 2 over 1 plus 2 times cosine squared of x over sine squared of x. So that gives me a final of 2 times sine squared of x plus 2 times cosine squared of x all over sine squared of x. But both have a 2 in common I can factor out. So sine squared of x plus cosine squared of x over sine squared of x. Sine squared plus cosine squared is 1, right? Using Pythagorean identity, that's a 1. So that gives me 2 over sine squared of x. And look, now they match. We've proved it. Okay, try the last problem. Pause the video for the student problem. Okay, student problem again. We need to combine these fractions. So at this point, they do not have common denominators. One has a 1 plus sign, and one has a 1 minus sign. So the left one needs to be multiplied by 1 minus sign over 1 minus sign, which is 1. Okay, and the right one needs to be multiplied by 1 plus sign, so 1 plus sign Okay, and we're going to ignore the right-hand side for now and just simplify the left to save some room. Okay, so I multiplied by 1 on both fractions to make them common denominators. So if I multiply by here, that's going to give me 1 minus sign. If I multiply here, that's going to give me 1 plus sign. And if I multiply if I add the bottoms, I just get the common denominator, which is 1 minus sine of x and 1 plus sine of x. So canceling the signs on the top, I'm left with a 2. And multiplying on the bottom gives me a 1 plus sine minus sine minus sine squared. Which again, the signs will cancel, leaving me with 2 over 1 minus sine squared of x. And 1 minus sine squared of x using Pythagorean identity is actually 2 over cosine squared of x. Okay, make a better square than that. And we'll box that. We could probably go a little bit farther, but we'll go back to the other one. So that's pretty close to what we have. We need to combine the circle now. So we'll move this over to here. So that's 2 over 1 plus 2 times sine over cosine. Alright, so we need common denominators, which in this case is cosine. So I'm going to multiply the top by cosine squared and the bottom by cosine squared. Okay, now we have common denominators. We get 2 times cosine squared plus 2 times sine squared all over the common denominator of cosine squared. We can factor out a 2, leaving us with cosine squared plus sine squared. all over cosine squared. And we know using the Pythagorean identity that cosine squared plus sine squared is a 1. So that leaves me with 2 over cosine squared, which happens to match what I had on the other side. Okay, that is the end of part 2.